Welcome everybody to 52 Living Ideas. I am enormously honored and just delighted to have Chuck Spinney here. He worked with John Boyd for almost 20 years. And
more than 20.
Yes, more than 20 years. And as you know, John Boyd communicated his ideas through briefings. And he gave those briefings to a number of people and a number of organizations within the military, especially the Marines, took to John Boyd's ideas. And after John Boyd passed away, I think the head of US Naval College asked Chuck Spinney to prepare a briefing, which he came up with his own briefing based on on John Boyd's briefing. But this is his own briefing based on that. He's been giving this dozens of times, since 1991, and I'm just delighted to have him give the briefing, give this presentation to us. So welcome, Chuck. The floor is yours.
Well, thank you very much. First of all, just to expand on what he just said, what Shrikant just said, after John died in 1997, he used to go and give a lecture on his paper, Destruction and Creation, to a strategy class at the Naval War College. And the professor of that strategy class was one of the reform group that we evolved beginning in the 1970s. And he ended up over at the Naval War College teaching strategy. Anyway, it was one of the most popular, I think he told me it was the most popular lecture in his class. And when John died, he was upset that he couldn't have it anymore. And he asked me, since I knew John so well, if I could do it. If I could put together a lecture, and I was very, very reluctant to do that. I mean, it's John's work, and I just didn't want to do it. So, but he prevailed on me. He just kept asking me over and over again, and so I put the first version of this lecture together, and I had to add some stuff of my own just so it didn't look like I was stealing everything of John's. I didn't want to even get associated with trying to take credit with it or anything. It was John's work. And one of the things I want to say is that any things, there may be some things I get here a little bit wrong from John. I knew him as well as anyone during this period. And I think from my perspective, it's got good fidelity with what he was thinking. He didn't see some of the stuff I'm going to show you. But I point out where that's the case. But it's my interpretation of his work, and if I've made any mistakes, it's my fault, not his. So anyway, the reason this paper is important, it's an abstract paper that he developed in a 3-year to 4-year period from 73 to about 1976. And his goal was to understand why he, a dumb fighter pilot with no background in design engineering, came up with the energy maneuverability theory, which literally revolutionized the way we designed airplanes. Now, I was in the flight dynamics lab as a lieutenant. I was an engineer and a design engineer. And I remember when the EM stuff was getting, the energy maneuverability stuff was getting popular, and it literally, I saw it with my own eyes, it literally changed the way we looked at how to design airplanes. We had been doing it basically the same way as the Wright brothers, but he came up with a whole new way of doing it. And his academic background was economics and industrial engineering, which industrial engineering is more of a, it's a technical management degree as opposed to a hardcore engineering degree, and here you have all these PhD aerodynamicists that never came close to coming up with an idea like this. literally that changed the way we went about designing airplanes. It literally saved the F-15. It was going down a bad road. At the time, it was called the FX back then. And I mean, I saw that personally. And it led to the evolution of the YF-16 and YF-17, which became the F-16 and F-18s, which are the YF-16 in particular was probably the most maneuverable fighter we have built since the F-86, surely since the F-86, and it's probably the most maneuverable fighter that's ever been built. So when I first met him, this was history. I had known that he was the father of energy maneuverability, which made him like sort of a god to me. I was a 28-year-old captain, and he was an old man of 45, 47, and I had seen what his theories had done, and I watched I watched him up close and personal because he was my boss at the time for the next 3 years as he wrote this paper, and he was definitely trying to figure out why he came up with the idea or how his brain worked. And so if you think of this thing, it can be used as a general theory, but it's basically the authoritative theory of that paper is the authoritative theory of how he thinks, if you understand what I mean. Anyway, let's get into it. And one thing I should mention, I encourage questions as we go along. This can get to be a long presentation if there are a lot of questions, and I will intervene and say, hey, we're getting to have too many questions if it looks like we're really getting bogged down. But anyone who wants to ask a question or make a comment, feel free to do so. And we'll just sort of work out the best way of doing it as we go on.
So folks, when you have questions, just go ahead and type exclamation mark in chat, so I know you have questions. And whenever you have questions, try to keep your questions brief. Go ahead, Chuck.
Yeah, okay. Yeah, that's good. Okay. This is, like I said at the beginning, this is my view. It's just a disclaimer. A lot of the stuff in this briefing was also developed collaboratively by myself and Chet Richards, who, as I understand it, has already been on one of your shows. Chet and I worked very closely over the years, although we never worked in the same office. And he helped produce a lot of the stuff in this that I'm going to show you. And of course, this is just a caveat. Any misrepresentation is my fault. A good way to start is after John became a strategist, and after he became known for his strategic thinking, he had a saying that machines don't fight war, people do, and they use their mind. That basically was about his theory of the OODA loop, and the OODA loop's about the mind. John never used that term before he wrote this paper. At least he never used it in front of me, and I was with him a lot. And I don't think he used it in front of Ray Leopold, who was the other captain who was working with him at the time, who's also talked about in Robert Corum's book biography of Boyd. So basically, to understand John's theories, you have to understand this paper. And this puts his paper in the context of his general theory of war or of strategy. Really, it's a strategy of conflict, strategy in conflict. Our subject is the left-hand bookend. This is the nuts and bolts that most people have looked at. That's where they come up with the OODA loop and everything. He doesn't mention OODA loop in here. His other bookend, which is in his it's another one of his briefings, is basically called the conceptual spiral. That's the other bookend, which is an elaboration of destruction and creation. So he basically spent 1973 to 1997 doing this work. And the bulk of which, for which he's most famous, is the red. But the stuff that was the basis for that are the bookends. I'm going to go over the first bookend. This is what got him off. And by the way, when he was first working on this paper, I remember asking him, I don't know how many times, why are you doing this? He said, well, I want to know how I came up with the theory of energy maneuverability theory. And I said, yeah, but where's it taking you? And he goes, I don't know. He says, I don't know where I'm going, but I'm having a good time getting there. And so he did not start this with the idea of going into this or eventually coming to this. This is actually more, the science and math is more related to our subject today. And basically the aim of the paper and the aim of this briefing is to try to understand how the human mind evolves an interior mental orientation, or what you might think of as changing constructs of meaning, or what Thomas Kuhn called paradigms. You've all heard the term paradigm, I'm sure. That permit individuals and groups to cope with changing external conditions, a changing environment. Incidentally, as an aside, the word paradigm is one of the most abused words in the English language now. And I have read that Thomas Kuhn on his deathbed deplored ever inventing the term, popularizing the term. I don't know how true it is. It might be apocryphal, but my guess is it's true. Anyway, our point of departure is, why do we make decisions? And basically, it goes to our biology. Our biological imperative creates purposeful behavior, or what you can think of as goal striving. And the basic goal is to survive, or more accurately, to survive on our own terms. Or put another way, to increase our capacity of independent action. And we live in an environment of limited resources and skills. So real world constraints limit that capacity for independent action and can threaten survival. The combination, so the implication is the combination of goal striving and scarcity sets the stage for competition among individuals and groups as they struggle to overcome environmental constraints. And the consequence is, to survive and grow free of debilitating constraints, individuals and groups must make decisions and take actions to overcome those obstacles and social competitors. So our focus is going to be, how do we generate the mental concept needed to support that kind of decision-making activity? Or put another way, how do we evolve mental concepts to identify what decisions and actions are necessary or appropriate? And how do we monitor the effects of those actions to support subsequent decision-making? And the simplistic answer is, we use a sensor system to observe events in the external environment. We orient ourselves to those events, we decide and we act, and then we observe the effects of the action and recycle. And many of you people who are interested in Boyd's work have seen a chart looking like this. But there's a problem with this simple portrayal. It doesn't really represent what's going on. And this is my first question for the audience. Does anyone have any idea what that problem is?
Folks, if you have any observations, go ahead and type an exclamation mark. Sanjay, just a second. Give me just a second. Hold on. All right. So it's going to be Sanjay, Aaron, and Chase. Folks, keep your answers brief so we can get as many answers as we go along, because there are going to be a number of places where you can give answers. So it's going to be Sanjay, Aaron, Chase, and Andrew. Sanjay.
Yeah.
Thanks. I think there are a few gaps here. The most obvious two that I'll mention briefly is, in terms of observation, we're limited in our ability to observe. We don't always see the full picture of reality in front of us. So that's very limiting here. Also, in terms of orienting, I mean, actually all of these are related in the sense that the level of information we have from the world is limited, and that will limit how effective a solution will be able to, and our action that we'll be able to take.
Okay.
Shall we go to the next one? You're welcome to respond. Go ahead.
I'll respond to all of them.
Got it. Okay, so it's going to be Aaron, Chase, Andrew, Mike, and Tom.
Oh my God.
Aaron.
Feedback loops. There's gaps in it. Without the feedback loop, you just don't have the evolutionary component tied to it.
Chase.
That's a very good point.
Seems to me like observe, orient, and act are all pretty self-explanatory, but decide is a small term for a big process.
Okay, next one.
Andrew.
Yeah, the piece I see missing is interpret after observe.
Mike.
Okay.
All of those things are complicated non-numerical partial differential equations, which you can't solve. However, you can come up with a piecewise linear solution. So you assume it's a straight line, which is the EM, his maneuverability equation, and you solve it as do the next step linearly, and then you get there.
Tom. Sorry, go ahead, Chuck. You were saying something.
No.
Okay.
Next one.
Tom and Kevin.
Okay, I've got a lot of things I'd say about it, but I'll simplify. The notion of purpose against which to evaluate all these concepts is not there at all.
Excellent. Thank you. Kevin.
Two things I would say is one is psychological. Second one is about the purpose, misinterpreted from observation. Thank you.
Thank you. Claudio.
Yeah, sorry. Yeah, it looks like it never ends, like an infinite loop.
Becky.
An interruption to the process doesn't restart it at the initial phase.
That's it. Chuck, over to you.
Okay, well, there's truth in everything that was said, no question about it. The point that I'm getting to is a little bit different, but it gets into the nature of orientation. Wait a minute. The problem with the simplistic answer is that all the observations of the external world are filtered through the cognitive apparatus of the observer. He might be mathematical, he might be artistic or whatever, but he's got a cognitive apparatus. And therefore your observations can't be separated from the various internal mental processes of each observer. The implication is any description of a complex reality can be viewed through a variety of mental perspectives that individuals and groups use to represent observed reality, or a multitude of different perspectives which make up one's mental orientation. The point here is we see things differently. Just compare myself to Shrikant. Shrikant's younger than I am. He's got a degree in computer science. I have a degree in engineering. My scientific education occurred before computers were a big part of that education. I was using them a little bit in college to do complex calculations. But when I was doing my engineering experiments and stuff, I was basically using French curves and plotting stuff on paper. Shrikant may have been computing least squares regression to do the same thing. We have different life experiences. He has a cultural background from India. I have a cultural background from Canada and the colonies, going back a long way, back to the 1600s. So we all see things differently. And basically what you have to do when you're working with an OODA loop is you have to come to a convergence of orientation, particularly if you're dealing with a group. You have to come to a convergence of an orientation that deals with the problem at hand, that works. That's the only criteria of success. It's got to work. And the real question is, how do you evolve that kind of relevant orientation for apprehending the complexity of observations in the real world? And basically, there's two ways of manipulating mental concepts to represent observations. One is through analysis, and the other is through synthesis. Analysis is breaking down a comprehensive whole into its constituent elements and looking at the relations among those constituents. Examples of analysis are logical deduction, mathematical differentiation, and ultimately destruction, because you're going down to parts. You can literally analyze something to death and end up with a bunch of disconnected pieces. I'm sure those of you in the audience who are writers have written a complex technical paper where all of a sudden you found yourself in a cul-de-sac where you had to throw everything out. That's destruction, a little too much analysis. We used to say analysts know more and more about less and less until they know everything about nothing in the Pentagon. The second form of thinking is synthesis. The synthesis is going in the opposite direction, starting with the parts and building towards a comprehensive whole. Examples of that are logical induction, integration, unconstrained integration from minus infinity to plus infinity. Construction, when you're building a house, that's a kind of synthesis. When you do it, an engineering design is a synthesis. You may do analysis in the process of building that synthesis. And that was the beauty of the EM theory, by the way. It enabled you to synthesize conceptual designs in a way that was never possible before. And so you could find a good starting point for your final design, or at least until you flew a prototype and it either worked or didn't work. Anyway, those are the two basic ways that our brain operates. I mean, some people have simplified it to left hemisphere, right hemisphere. It's possible other organisms that have evolved under different constraints have different mental constructs of figuring things out. For example, porpoises basically see with sound and they communicate with sound. So that's very different than what we do. We see in a integrative way, and then we break it down into a string of words. So we have to analyze what we see to break it down. So it's a product of evolution, but that's basically what we're faced with, for better or worse. Now, what I'm going to do is discuss these in a little more detail. I'm going to show how the interplay of observations and orientation. I'm going to try to describe the interplay of observations and orientation, and in so doing, introduce the dialectic nature of understanding and creativity. Understanding is related to analysis. And what I'll do is give you an example of analysis of a pre-existing domain. And I'm using domain in the mathematical sense of the term, where it's a constrained universe. Nothing exists outside of the domain for you to look at. It's a sealed system, so to speak. And then I'm going to use an example of creativity, which is analysis and synthesis. And this is a particular, when I get into this thought experiment here, if people have seen this before, they're not allowed to ask questions because it'll wreck it for everybody else.
All right, let me underline that. Folks, if you're familiar where things are going, do not use the fact that you have, don't say anything at that point.
Right.
Okay, only if you're unfamiliar with what is being said, then you can answer the questions about guesses. All right,
Yeah.
Go ahead.
Okay, and then I'm going to give you a historical example, and it's some that many of you may be familiar with. It's the evolution of cosmology. Okay, let's first look at analysis. That's basically understanding in the context of a simple domain. Basically, what you do is very simple. You gather a variety of observations about that domain. You break it down and correlate those observations from a variety of different perspectives. And then you combine these correlated perspectives into a comprehensive description of the domain. And as the most you can get out of this exercise is understanding the domain. You haven't created anything new, but except for the understanding. And a simple example of that is a pyramid. You can look at a pyramid. We're not going to look inside the pyramid. Let's just say the domain is the outside of the pyramid. You look at it from the bottom or from the top, you have a square with dissecting diagonals. If you look at it from the side, you see a triangle. If you look at it from a corner, you see a triangle with a bisecting vertical line. And if you look at it from the bottom, you see an opaque square. Combine those together, you could rotate it on a computer with a computer graphic, and you get a feel for what the pyramid is. So you basically analyze it from these different perspectives and correlate and combine the relationships among those perspectives to get a comprehensive description. Now, the key point here is the dissection and reassembly can produce a richer understanding, but it's like a constrained integration in calculus. It always takes you back to a specific answer, the same pyramid in this case. So you don't come up with anything new other than, you know, maybe better understanding. Oh, sorry. Now, this is the thought experiment where people are not allowed to talk if they know where it's going. This is the basic idea of creativity is you replace an existing order with a new order. And let's now imagine 4 separate images or domains. Same definition of a domain we just had. Each image is a pre-existing whole with a unique identity. And there are no relations among the domains. Now this is basically an artificial example. And like the skier on the ski slope incorporates many more parts than described here, but these are the only parts in this domain. Speedboat, ditto, toy tank, ditto, bicycle. They have no relations among each other, and they're made up of these and only these parts. So let's go to the next slide. Wait a minute. We can do analysis of each domain, just like we did on the pyramid, basically by looking at the parts and the relations among the parts, which is, you know, exampled here. And each domain is in the square thing. Now let's shatter the correspondence between the parts and the domains. That's a form of analysis, taking it to its limit. Literally know more and more about less and less until you can know everything about nothing. Just have this stuff swimming in this sea. Now there's something, what we've done is we've tried to shatter the correspondence between the parts and the domains, but there's something that's not quite right with this picture. Does anyone have an idea? Let's not have a long list, just 1 or 2 people.
Folks, if you have an answer, you can go ahead and type a exclamation mark and I'll call upon you. What's wrong with this picture? It's still color coded. David Johnson says it's still color coded. Anybody else?
He's got it.
Okay.
So let's basically what this is an example of. How many people here have been in a meeting where the boss has said, we're going to think outside the box? You know, we're going to be creative. Of course, the box constrains what you've seen, and the color coding were the boxes. You couldn't, the boxes were still there. And when you first shatter that, the boxes are there even in your recessed consciousness. You know, the skis came from the skier on the ski slope. And so they influence what you see, or more abstractly, the pre-existing domains are constraining your orientation and imagination. Now let's shatter the correspondence again. Now what we have is uncertainty and disorder in the place of meaning disorder. Does anyone have an idea of how we might construct something meaningful out of this? Now imagine that you're on a battlefield and I got a gun on your head and aimed at your head, and you got to answer that question. You don't have time. You got to do it fast. That's the essence of the OODA loop in conflict. Any ideas?
Madeline, go ahead. Folks, again, keep your answers very short. Madeline. Says, give me just a second, okay? Let me see if there is.
Hi, can you hear me now?
Yes, go ahead.
Okay, yes. What I would do is I would group the different things by function. So I would group all the mediums together, like water or air or land. I would group the the type of thing where the vehicle would meet the surface. I would group all those together, so like wheels, treads, the bottom of the skis. So I would group them by function and then start putting them together.
That's a good way of looking at it. That's pretty much the next slide.
Do you want to take other answers, or shall we move on?
No, we can move forward on this.
Go ahead.
She came up with an answer that enabled us to move forward. If we can find common qualities connecting threads, attributes, or operations, which is what Madeline was talking about, among some of the constituents swimming in the sea of anarchy. Now, does anyone see anything now?
Right. Anybody now? You can go ahead and type exclamation mark again if you have not.
Don't worry if you don't. It's no big deal.
Okay, Chase, go ahead.
I don't have.
Oh,
anything.
no. Okay, Sanjay.
Well, let's go to the next slide. Maybe something will come up now.
Yeah, I was talking about the energy relationships. Some of those things had various types of energy and motion.
How about this?
Right.
They have to do with motion.
Yeah, the point is, if you think about the idea behind the snowmobile was invented after all these other things were invented. All those parts existed, and it came out of someone with an imagination that just started combining things. And the idea now is, if you start looking at these parts in the yellow, the original domains are now suppressed. These parts now have a slightly different meaning. Treads aren't metal, they're rubber. Handlebars have a slightly different meaning. We don't have an outboard motor, but we got the same kind of motor, almost identical, to power it. And of course, you got the skis used in a very different way. So the snowmobile was a new creation. And in fact, it was invented and became a very successful marketing, became a very successful innovation over time. And the important thing to remember about combining these parts is snowmobiles are the exception. Most times we start combining parts like that, you end up with bad ideas that don't work. And that's why you do prototyping in engineering, for example. And they may not work because they're not marketable. You can't create a market for them. You can't produce them. They may not work because they're stupid ideas. Here's an example of some somewhat similar syntheses that have been done that have sort of passed into the history books and then out of the history books into the dustbin of history. Actually, this vehicle here, this was a German tread. It's a combination of a tank and a motorcycle that they used on the Eastern Front in World War II, and it was basically a disaster. It was a typical piece of techno junk that the military is prone to make. But if you go to the web and start searching for these things, you'll find there's a whole school of people that just worship these things. This one is a more obvious disaster. So the important thing to remember is you just start slapping things together. It doesn't mean they always work. And in fact, most of them don't work. New concept descriptions or new startups just don't work that well in the real world. Occasionally they explode and work brilliantly, like the snowmobile, but more times than not, they become forgotten. And that's one of the problems with creativity. Now for something like, for a new idea or a new conception like a snowmobile to be viable and remain relevant, it has to be continually refined by checking and verifying its internal consistency and reversibility. In other words, you can go from the parts to the whole and from the whole to the parts, back and forth, and the thing hangs together. And that would imply a new mathematical theory, a new physical theory, a new piece of technical equipment, whatever, new piece of software. And you have to check its matchup with external reality. In the case of the snowmobile, you know, can we create a market for it? That took time, trial and error, but they did create a market. Can you produce it economically? Can you get the parts and all that type of thing? That's the kind of reality the snowmobile had to deal with. But the key point here is when you're, particularly when you're dealing with complex abstractions, that as the focus of effort turns inward to refine the precision or subtlety of the observations and the concept description, in other words, the design process, the newer level of precision or description will eventually exceed the original level of precision. And when that occurs, you should expect to see mismatches, inconsistencies between the newer and more precise observations and the concept description of those observations. You can ask yourself why. Well, basically it's logical if you think about it. If we assumed otherwise, it would be the same as saying newer or more precise or different observations and interactions will always combine to produce the same synthesis as the older, more primitive observations and interactions. Now, I want to give you a real world example to clarify this point. And this, I put this together after Boyd died, so he's never seen it. It's the evolution of cosmology, or our mental orientation toward celestial observations. Those of you who have been interested in the history of science will recognize much of this. This is pretty standard stuff in scientific literature. It's not entirely comprehensive, but I think most historians of science would agree that I'm talking about the major factors here. Excuse me. We're going to start with what used to be called the music of the spheres, or the Ptolemaic universe, which was the Earth-centered universe. Claudius Ptolemy was a Levantine Greek who lived somewhere around 140.
Chuck, could you move a little bit ahead? We are able to just see. Yeah, that's perfect. Perfect. Go ahead.
I'm sorry.
No problem.
Claudius Ptolemy was a Levantine Greek in around 840 AD, and he basically was probably the principal driver of this idea, is probably the best way to describe it. It wasn't solely his idea. And the idea was that the Earth is the center of the universe, which is made up of 8 spheres which rotate around the Earth. The outer sphere held the stars, which rotate in perfect circles around the Earth. Each of the 7 inner spheres held a planet, and the planets were defined as our moon, the sun, Mercury, Venus, Mars, Jupiter, and Saturn. They were basically different from the stars because they moved in different ways. And that rotated smoothly around the Earth, but along a complex curvilinear path. And the only way they could produce that complex curvilinear path was to lay on epicycles on the circumference of the sphere. Now, an epicycle is a small circle, which you can think of as a small orbit that's circling around as it's rolling around the sphere. So in some cases, you will see a planet go like this overhead, and then it'll loop back, and then it'll loop back again, just depending on where the different planets are in their orbits. And you couldn't explain, and basically the epicycles were the only way they could make sense out of the motion. And it turns out, if you kept piling epicycles on top of epicycles, you can just about match any kind of curvilinear motion. It's sort of like doing a regression analysis of 100 variables of 100 data points with 99 variables. You get a perfect fit every time. But there was a problem. There was a problem with this. It gave a very good agreement with the timetable of the planets, and it basically served the needs of the time very well. And in fact, the instruments that they used to make these measurements and the models they made of this universe were amazing in terms of their detail, complexity, and precision. I saw a bunch of them a few years ago in Dresden, Germany, and I was absolutely astounded at the scientific precision of these instruments. They were really impressive. They gave a reasonable agreement with the timetable of the planets, but whenever people made more precise observations, you know, people with better eyesight or clearer nights when they're on top of a pyramid or whatever, they have to pump in changes, and they had to tinker with the epicycles or add epicycles, and it got more and more complex over time in order to maintain the matchup of the complex description and observed reality. The result was an ever increasing inward focus of effort. Now I'm bringing us back to the point I made on synthesis, as the astronomers and mathematicians struggled to update that worldview with the new data. And consequently, by the 1400s, the internal complexity of the system had fatally weakened its intellectual coherence and set the stage for a new synthesis. Now, as an aside, think about the situation we're in today where computation is easy. We've mechanized computation. The computer's essentially like the steam engine that way. And so basically what you would do to update a Ptolemaic universe, assuming you had no better sensors today than you had back then, but you had computers, supercomputers, you push the button and you recalculate. The incentive to change is much less. I submit that we see a lot of that kind of nonsense going on in these complex nonlinear computer models like climate models, ACMs. That's just me talking. Boyd never talked about that. So by the 1400s, people were saying, is this thing, essentially it was so complex and it was so hard to fix. They were saying, is this a product of God or a product of the mind? Is it a product of us? It became more and more looking like a product of us. And that's what set the stage for the synthesis. People began to doubt. And if you look at the destruction of the Ptolemaic orientation, there were many precursors. These are probably the four biggest and most important. I think if any historian was putting together a list of precursors that destroyed the Ptolemaic system, it would include these four. It might include some others. These serve to illustrate the point, and they are definitely the biggies. Copernicus, most of you have heard of him. He simplified the Ptolemaic system with what we would call in business a paradigm shift, a word that the inventor of the term hated. Basically what he did is he came up with a simplified mathematical description by assuming the sun was the center of rotation. He had a real problem though. He assumed erroneously that the orbits of the planets were perfect circles. And his predictions didn't match the detailed observations. In fact, the Ptolemaic universe gave better observations in some case. So he couldn't get rid of all the epicycles. He ended up pumping epicycles into his system. The second precursor, and he's the least known of these four, is a guy named Tycho Brahe. He was a Danish astronomer. I think he was Danish, he might have been Czech. He was in Denmark when he did it. And he increased the precision of the observations. And he was an extraordinary man. He did not have a telescope, and he assembled a huge database of very precise observations. And he thought Copernicus was nuts. He liked the Ptolemaic system, and his database was to prove the Ptolemaic system worked. Next one was Johann Kepler, who basically gave a precise mathematical description of the sun-centered universe by assuming the orbits of the planets were ellipses. And he ended up with three laws of motions. The first law was the orbits are ellipses, not circles. Each planet swept out an equal area per unit of time. as it went around the ellipse. And then he had a formula for the year squared was a constant times the distance from the sun cubed. He was obviously a pretty good mathematician to come up with that one. But basically he came up, he basically solved the Copernican problem. And then you have Galileo. Galileo, his contributions were mathematical precision, experimental method, and a basis in physics. He invented the pendulum as a precise measurement instrument to measure time. He proved falling objects could accelerate at a uniform rate regardless of their mass. He came up with the idea of inertia. That is, a mass will keep moving unless some force acts to stop it. And he used a telescope to postulate the divine clockwork or rotation of Jupiter's moons. He ended up in a religious inquisition because of that, because it went against the Pope's teachings. And in fact, there's an interesting. It's really ironic. Galileo was told to shut up by a religious inquisition because they were supporting the Ptolemaic universe, which was made by a non-Christian, or certainly a non-Roman Catholic. And in the late 1970s, some of the Vatican archives were opened up, and they found that one of the documents used to charge Galileo was a patent forgery. You know, so it was a put up deal. But anyway, Galileo was told to be quiet, but the book that he wrote about the moons going around Jupiter made an indelible impact. The Earth couldn't be the center of the universe because Jupiter was the center of something. That was the problem. Well, Newton was the one who put everything together, and Newton had his own snowmobile, and it was the universal law of gravitation, and his basically that provided forces that explained what Kepler had seen and what Galileo had seen, or what Kepler had calculated and Galileo had seen. I'm sorry. And he built on those other peoples by these vectors. You can see them. This is probably, in my opinion, based on my understanding of scientific history anyway, is probably the greatest takedown in the history of science. Basically, he converted everybody to his way of thinking, to his orientation in about 50 years, or the vast majority of people, not everybody, obviously. And he did it with his four things. Through orbital dynamics, basically mechanizing Kepler's three laws with gravitation, using the more precise observation to prove the point, coming up with his three laws of motions, which were derived directly from Galileo, and he invented the infinitesimal calculus. Now, another guy invented it at the same time independently, and that was Gottfried Leibniz. And that started a war between Leibniz that goes on to, and Newton that goes on to this day. But the result was an elegantly simple mechanical orientation that predicted the motion of the planets with stunning accuracy. It was a complete wipeout, took everybody down. In fact, Newton's orientation became so powerful, it served as an example for other fields, like political science. Montesquieu basically used some of Newton's ideas. The original classical economics was based in large part on Newtonian thinking, and many other areas as well. So he not only shaped the cosmology, he shaped the way we the way mankind looked at everything at that time. And basically, just from the scientific standpoint, coming back to psychology, or I'm sorry, cosmology, actually, there may not be that much of a difference. The Newton orientation shaped observations and experiments for the next 200 years as science turned inward to flesh out his ideas. And that also, if you think about it, the Newton orientation also helped to shape the explosion in technology, and the new technology led to more precise instruments and more subtle observations. So the experimental evolution was inward focus plus more subtle observations, going right back to the point we were making earlier. That set the stage for eventual mismatches between Newton's predictions and experimental observations. And probably the most spectacular example of that was the Michelson-Morley experiment in the late 1800s. Basically, they were trying to calculate the speed of light. And Albert Michelson had constructed an interferometer as a tool to permit a more precise measurements of the speed of light. And the differences, the idea was to measure the differences in light waves by measuring the size and number of black and white bands, which showed up as interference. They were really interference fringes produced by the interferometer, which appear when the light waves get out of step with each other. As most of you probably know, light has effects much like a particle in some cases, like photon, or much like a wave. And if the wave effects get out of step, an interferometer can detect that. The aim of the experiment was to use the interferometer to measure the speed of the Earth through the ether, which was what they used to call space back in the 1800s, by comparing the difference between the speed of light and the direction of motion and the speed of light perpendicular to the motion. That's basically, that's a standard Galilean transformation. Excuse me. Oh, I got a problem. Hold on. Okay. It's a standard Galilean transformation. If you're in a car going 50 miles an hour and you throw a baseball forward in a straight line parallel to the Earth at 20 miles an hour, the baseball starts off at 70 miles an hour. If you throw it vertically, it's going 50 miles an hour in the forward direction and 20 miles an hour in the upward direction. That's what a Galilean transformation enables you to do. And that was implicit in the Newtonian orientation. The Newtonian orientation had two universal constants, gravitation and time is what enabled you to make the Galilean transformation. Michelson and Morley's assumptions and the predicted observations were shaped by the Newtonian orientation, which no one questioned until the late 1800s. There were other experiments. Michelson-Morley was the most well-known one. There were other experiments at the time that also suggested there might be something wrong with Newton. But Newton stood like a god in the 1800s. How could you question him? It was a lot harder to question Newton scientifically than it was to question Ptolemy on religious grounds, because Newton had proven so much and had done so much and created such enormous consequences. Anyway, Michelson-Morley's assumptions and predicted observations were shaped by that orientation. They assumed the ether, or space, was an inertial medium that carried both light waves and the Earth. And they assumed the Galilean transformation would work, that the speed of light in the direction of the Earth's motion was the speed of light plus the Earth's speed, and the speed of light perpendicular to the Earth's motion was the speed of light. So you basically subtract them and you get the speed of light. Well, they knew the speed of the Earth, so then they can calculate the speed of light. So the experimental results were the actual observations didn't fit the predicted observations, which flowed out of the Newton. No one questioned the prediction. No one questioned the methodology. It was very sound methodology if you accepted the Newtonian orientation. And the reason they were incompatible was there were no interference fringes, which implied incorrectly the Earth was not moving relative to the ether, or more accurately, an inertial frame of reference. We all know we knew at the time the Earth was moving. And the experimental result was the speed of light plus any other velocity equals the speed of light, which is impossible under Newton. And this really shook things up. And they did this experiment, I can't remember exactly now. I think they did it over a period of 7 years, over and over again. They couldn't believe their results. They were good scientists, and they basically said, we've done something wrong. And they kept doing it. And finally, they came to the conclusion that there was nothing wrong with their experiment, but they didn't have an answer. And, you know, it took Einstein to come up with the answer, which brings us to the next slide. Einstein's idea was the special theory of relativity. Einstein resolved the anomaly by changing the universal constants in the Newton orientation. He still had two universal constants, gravity, like Newton, and the speed of light in the place of time. He basically said time wasn't constant, but the speed of light is constant. And the result was a new way of looking at things, or a new snowmobile. Now, we're getting into areas I don't understand as well as what we've discussed up to this point. But basically, the Galilean transformation was replaced by what is known as the Lorentz transformation. And put simply, a moving object will appear to diminish in length in the direction of travel as its velocity approaches the speed of sound, speed of light. Or a moving clock will appear to be running more slowly as your velocity approaches the speed of light. Now, one of the reason I put in the moving clock is one of Einstein's key thought experiments in coming up with these ideas was he imagined himself on a train leaving Zurich, I believe, and there was a clock tower. And he said, I can see that clock tower with perfect accuracy forever, but I'm going to accelerate my train till I'm moving away at the speed of light. What will the time say on the clock? Well, the time won't change because he's moving away at the speed of light. And that was one way how he initially explained itself. It was a real elegant thought experiment. Anyway, the universe, Einstein's basic idea is the universe must be thought of, and he means mind, as a continuum of space and time. This is where mind, time, space comes from. It's a single concept in Einstein's ideas. And it's a measure of separation that involves spatial and temporal terms. Yeah, right. So basically, we can make a generalization from this little trip through cosmology. Each new synthesis shaped the nature of the future observations, as well as the research program for developing the concept description. On the other hand, the evolution of cosmology from Ptolemy to Einstein shows how the interplay of observation and orientation, the interplay of what you're looking at with the cognitive apparatus of the mind, going back to the very beginning, produces a never-ending cycle of increasing mismatches, destruction, and then creation, something new, a new way of looking thing, which collapses things down, and then you go through the cycle again. And over time, orientation to the world changes in a non-cyclical way. We don't go backwards. There's only one way. It's a one-way vector of time, in this case, for the evolution of this kind of orientation. You don't go backwards. Now, historians, especially Thomas Kuhn, who wrote a wonderful book called The Structure of Scientific Revolutions, very famous book, it's very small, short, really worth reading if you're interested in these things, have recognized this pattern. What Boyd did is that he went further by arguing, and in essence, if you think about it, when Boyd developed his energy maneuverability theory, he went through a similar type process. He bypassed some of the earlier constraints because he didn't do design work as an early. He was a fighter pilot with an economics degree and an industrial engineering degree. But he basically went through a similar type pattern where he came up with a different idea for doing conceptual design of airplanes with the energy maneuverability theory. And what Boyd did in this paper, and this is why it took so long to write the paper, I think really 5 years is probably the best amount of time. I was there for that entire time, as was Ray Leopold, who's also described in Boyd's book. And we were both 28-year-old captains at the beginning of the process, young guys. And so we were, the way Boyd thought was he thought in a Socratic way, where he couldn't think without bouncing ideas off of people. And his friends became people who responded to his ideas in ways that he found useful. I responded to his ideas differently than Ray. Ray is a PhD electrical engineer, and he's got a much tighter logical mind than I do. I've got a much looser mind, but I may be a little better at speculation than Ray. I'm not sure that's true, but we provided different assets. That's the key point here. He thought about this in a Socratic way. So I can speak with absolute certainty that he had no idea where he was going when he started. He just wanted to know why he came up with the energy maneuverability theory, and other people didn't. And he basically ended up here. And Boyd went further by arguing that there were theoretical reasons why the destruction and creation cycle is an inevitable fact of life. Now, it's an inevitable fact of life for our brain structure, for our cognitive apparatus. It might not be for some kind of different brain structure. It might not even have any meaning for some kind of different brain structure. And Boyd's theoretical reasons were based on three sources. One of them was the proof by Kurt Gödel, who some of you may be familiar with. For those who aren't, Kurt Gödel was a young Austrian mathematician who I believe he was in his 20s, it was in the late 20s or 1930s, came up with a theory that is known shorthand as Gödel's proof. And basically he said any consistent system of axioms is incomplete, and that is that it contains true statements that cannot be deduced from the postulates that make up the system. In other words, you can't understand a system of axiom in its totality because it's incomplete. Jacob Bronowski, who is one of my favorite philosophers of science, had a wonderful term for Gödel's proof. He says it was a remarkable and remarkably unwelcome proof because it really blew things up. And it stood the test of time. And Claude Shannon did some work that basically was very similar to. He did it after Gödel, and Lowenheim and Skolem also did some work. So it's been shown over and over again. It's pretty well accepted now. It's accepted as one of the brilliant logical proofs of the 20th century. John basically said, oh, and the thing I forgot to mention was what made this proof so devastating was the system of axioms that he used to prove the point was simple arithmetic, the simplest logical system that in existence. If the problem exists for simple arithmetic, it exists for every logical system. John looked at it, he sort of looked at it through a slightly different lens and said, and he turned it around a little bit, but it says basically the same thing. He said, even though a system may be consistent, its consistency cannot be demonstrated within the system. You have to appeal to some systems outside of it. You have to bring in some external help. The second point is Werner Heisenberg, the second theoretical reason for the eventual mismatches. Basically, Werner Heisenberg was a German physicist. In the 1920s, he came up with the famous Heisenberg uncertainty principle. He was trying to measure the position and velocity, or really the momentum of an electron. The only instrument you could use that you could control to try to measure an electron with was another electron. So the element of precision was, the precision in the instrument was the same as the precision of the observation. The generalization, and he said you cannot simultaneously determine the position and velocity of a particle. Basically, that's because the electron had a interaction with it that you couldn't take out of the observation. It moved it or kicked it up to a higher energy level or whatever. John's generalization was, when the precision of the observer approaches the precision of the observed, the observer perceives uncertain and erratic behavior. And then the final one is the second law of thermodynamics. The second law of thermodynamics basically says all natural processes create entropy. And the generalization is entropy must increase in a system that cannot communicate in an ordered fashion with other systems external to itself. Any mechanical engineer who understands thermodynamics would agree with that statement. The interesting thing about the second law of thermodynamics is, entropy became a very popular subject in the 70s and the 80s. A lot of books were written about it, and it became philosophically, everybody talked about it. But if you go back to the discovery of the second law, which took place over a period of time in the early 1800s, basically with people trying to understand steam engines, if you look at all of science at that time, it involved reversible processes. Newton's universe was reversible. Maxwell's theories were in electricity were reversible. The second law of thermodynamics was the 8-ball. It only goes in one direction. It's not reversible. Entropy increases if you can't communicate with the outside world. Your body basically takes energy, information, and material from the outside world, processes, and expels waste. You die when you lose your ability to do that because your entropy builds up inside and you turn to dust, which is max entropy. So the second law was like the 8-ball of the scientific revolution. It basically didn't work like everything else, and people had a hard time with it. But the problem was, the more you looked at it, the more you said, man, this may be the real law, because it had more to do with everything you see. Anyway, it stood out there as a sore thumb. I remember when I first started learning about the second law in engineering school, it was, you're schooled in Newtonian physics and stuff. It was hell to understand. Anyway, John took these 3 ideas and he built a snowmobile. And Boyd's snowmobile is this statement: one cannot determine the character and nature of a system within itself. Moreover, attempts to do so will lead to confusion and disorder. Now, this statement is at the center of his theory of conflict. He came up with this idea before he had any idea that he was going to go into a theory of conflict. He had no idea where he would evolve after he did this paper. I know that for an absolute fact. I was there. I saw it with my own eyes. He used to tell me over and over again, I don't know where I'm going, but I'm having a good time. And when to understand the OODA loop, you have to understand this statement. That is at the core of his idea. And basically, it's how, and his core idea of the OODA loop is how the mind works in competition and conflict, not necessarily shooting conflict, any kind of conflict, intellectual conflict, political conflict, bureaucratic conflict, you name it. This idea is at the center of it. You get the person to turn inside. When he says, I'm going to operate inside a guy's OODA loop, that's what he's talking about right there. Very few people understand that, unfortunately. He didn't explain it in his briefings on war. You go over to the military side of the house, even the Marine Corps, which has done more work on his stuff than anyone else, and they're interested in where he starts at the beginning of his history of conflict, and they don't understand that. That's why one reason why I've given this lecture so many times in the Marine Corps school system is there are people in the Marine Corps that do understand this, and many of them are instructors that they're in their schools at Quantico Marine Base south of Washington, and they're trying to teach this to their students. But when you're in a doctrinal organization, it's hard, and particularly in organizations where if you start coming up with questions and stuff like that, you might not get promoted. So the implication is we're dealing with a never-ending cycle of increasing mismatches, destruction, and creation. And that's the natural manifestation of a dialectic engine, an analytic synthetic process powered by a continuous effort to survive and improve one's capacity for independent action. We're going full circle back to the beginning. And that's regulated by alternating cycles of entropy increase toward more disorder and entropy decrease toward less disorder. The evolution of cosmology showed how that happened. Newton brings things together, then they started coming apart again. Einstein brought them together. Sooner or later, he's going to start coming apart again. Now what I want to do is I want to probe more deeply into the nature of observations and the relationship between observers and the observed, because that goes to the core of what we're talking about. The relationship between the observer and the observed, because that deals with your orientation. And the way we can synthesize these observations into a useful picture of reality. What we're going to do now is we're going to probe a little more deeply into the nature of observations and the relationship between the observer and the observed, and the way we synthesize observations into a useful picture of reality. And this is going to get us into a discussion of the OODA loop per se. Now the next chart is the monster chart of the briefing. And I'm going to have to read from it because it's building blocks for what follows. And I apologize if people find that a little distracting. Basically, if we can categorize observations by the interaction between the observer and the object of observation. And in classical physics, which is basically science up through Newton before Einstein, we assume that the universe was a system of reversible deterministic events that exists as an objective reality independent of the observer. Observations are events in themselves, and a complete description of these events is theoretically possible. Uncertainty about the description is therefore the result of ignorance. Now, this is Jacob Bronowski. He was a great philosopher of science. He probably did the best TV series ever done on the history of science and culture, called The Ascent of Man, in the late 1970s. And it's still great to watch today, even though a lot of the science has changed. And he was a mathematician, very prominent mathematician. But the key point is uncertainty about the description is therefore the result of the ignorance. And there's no relation between the observer and the observed. This is the theory of the objective observer. Relativity is Einstein. He changed that. He said the universe was a reversible system of deterministic events. He modified it. He didn't really change it that much. That exists as an objective reality, but one's description of that reality is dependent upon the position of the observer in the system. Between each event and observer, there must pass the signal, a ray of light in his case, which cannot be taken out of the observation. The fundamental unit of observation is the relation between relativity, relation between the signal, the event, the signal, and the observer. Uncertainties about the system as it is are the result of ignorance. Einstein was fond of saying God does not play dice. He was the last classical physicist. But some events are unknowable to man because of the nature of the signal. And for the constant speed of light makes it impossible to apprehend simultaneous events at a great distance. And in fact, simultaneity has no meaning because the light carries the message. In quantum mechanics and the principle of complementarity, which is basically what came out of Heisenberg's work, it's Niels Bohr's interpretation of Heisenberg's uncertainty relation. He says, events at the atomic level can only be described in terms of alternative possibilities and relatively probabilities of occurrence. Heisenberg showed why it is impossible to make precise simultaneous measurements of the position and momentum of an electron. Bohr interpreted this result to mean the interaction between the object of observation and the quantum system and the observing mechanism is non-decomposable. You can't get the interaction out of it. and no single observation or observing mechanism can completely describe the system. And while various observations may describe complementary portions of the same reality, it is impossible to combine them into a single complete description of the whole of reality. And those definitions are from Botanica and Ilya Prigogine, who wrote a great book on complexity theory in the late 70s, early 80s. And then there's the natural science, which is evolutionary biology, anthropology, culture, epistemology. And sources of this kind of thinking are Charles Darwin, Konrad Lorenz, Donald Campbell, E.T. Hall, and turns out Boyd, although he wasn't thinking exactly along these lines at the time. Looking back retrospectively, he would definitely be included in this group. Events in the external world are perceived through an evolutionary cognitive apparatus, a neurosensory system that acquired its present form through an interaction with and adaptation to the subset of events in the world that affects survival. If you think about our cosmology thing, that's exactly what we were doing, looking at subsets over time. And they related to how well we could exist in our world, which is a way of thinking about survival. Since these sensing mechanisms superimpose partial images of the outer world on fluctuating internal mental states, fluctuating mental states of the internal neurosensory organization, it is necessary to compensate for physiological and psychological mechanisms in the observer to come up with a viable image of reality. Well, this last one is where the OODA loop lies. And what I'm going to do on the next slide is I'm going to show you the differences between these. I had to go through these to make the differences meaningful. So I apologize if it was too confusing. We can categorize observations by the type of interaction between the observer and the object of observation. Basically, Newton, and the philosopher of Newton was Simon Laplace, and I would add most defense analysts, social scientists, and economists today, said there's no interaction. The unit of observation is the object of observation. We can have an objective view. That's where the sterile theory of the objective or absolutist observer comes from in social science. And it basically is a leftover from the impact that Newton had on philosophical development. Einstein also said there was no interaction, but he said the unit of observation is more complex. It's the object, the signal, and the observer. And that has led to the sterile theory that everything is relative in social sciences. And it affected art, it affected all sorts of things. Heisenberg and Bohr basically were talking about a one-way interaction. The process of observation shapes the object of observation. Units of observation turn out to be alternative possibilities and relative probabilities because of the shaping effect. The electron hits the electron, it changes its condition, so you don't know what its condition was when you wanted to look at it. It's like trying to measure a pool ball on a pool table by rolling a pool ball toward the pool ball you're trying to measure, counting up the time, you know the exact velocity, you don't know the measure of elasticity in the pool ball, and you don't understand the friction. So you can't measure where that pool ball was by the way they bounce. And then if we look at Darwin through Boyd, which is a summary of what I just said there, this is the most subtle way. What we have is a two-way observation. The observing apparatus shapes and is shaped by the object of observation and the interaction of environmental pressure. In other words, it's a co-evolution taking place. The effect of the observing organism and the interaction with environmental pressure. And the units of observation are the subset of external events which affect the observer's survival. To understand the OODA loop, you got to understand this statement at the bottom here. Now, Boyd he never saw me break this down. I did this after he died. I'm sure he's dead, so who knows, but But I firmly believe in my own heart he would agree with what I've said here. I don't think he'd find anything to disagree with. So now what we're going to do is we're going to try to bring these ideas together. Going back to that first or second slide. What we're going to try to understand is what Boyd was getting at when he said machines don't fight wars, people do, and they use their mind. Really what he was saying, machines don't determine conflict. It isn't necessarily wars. People do and they use their minds. And the Boyd synthesis, one cannot determine the character or nature of a system within itself. Moreover, attempts to do so lead to confusion and disorder. These are related statements. And this is why the simplistic mechanistic interpretation of the OODA loop really misrepresents his ideas. And it leads people to think, well, we'll just speed this thing up and everything will be fine. It's not about speed, it's about agility. And agility means you got to get inside the orient. Our discussion of the relationships among analysis and synthesis and observation and orientation show that orientation is the heart of the OODA loop. You don't understand what he meant by orientation, you'll never understand his ideas. The mechanical cycle says nothing about it because orientation is different for different people. We all have different backgrounds. We're different ages. We have different educational experiences. We see the same thing differently. I definitely see a computer differently from Shrikant because he can operate his better than me. But I bet you I can use the French curve better than Shrikant.
True.
Orientation, if you think about it, in its simplest term, orientation shapes how we see as well as what we see. And the how we see evolves over time, which brings us to Boyd's initial sketch of the OODA loop. Now John, Chet Richards, and myself worked out this sketch in the late 90s and in the late 80s and early 90s before John died. And he basically, this is what he settled on. We floundered around with it, and then we spent a long time discussing whether or not it was even a good idea to have a sketch, because then people try to figure out how to computerize it. And next thing you know, you'll have an aircraft designer designing a heads-up display with an OODA loop on it, trying to work his way through it in a dogfight, because that's how our technology community works in the Pentagon. But anyway, we finally decided it was a better idea. John finally decided it was a better idea to do it. So at least we got the ideas down the way we thought, the way we were thinking at that time. So what we're going to do is explain the implications of his idea. And the key thing I want to remember is this is an abstract discussion. This is a sort of a pedagogical type thing. You don't work your way through problems saying I'm going to start here and then go here and then start with observations and then go into my genetic heritage and all that crap inside the orientation and then come up with a decision and action. But anyway, let's talk about the implications of this chart. But keeping in mind, it is an abstraction. It is an abstraction of what John thought at the completion of his work. He signed off on this. The only thing that's different about this chart and what he saw was that he did it by hand and Chet and I cleaned it up. It's identical. So what we're going to do now is we're going to describe different parts of the OODA loop and see how it interacts with the external environment. This discussion was jointly evolved by Chet and myself from time to time over John's death. We didn't just sit down and do it. We've been doing it over the years. He may call me up and say, hey, I got an idea. And 6 months later, I got an idea and we might change something. The key thing is that it was built after what we're going through now was done after John's death. Chet has some more description at this web page here, and everybody's going to get a copy of this briefing after this is over. So, and if I've misrepresented anything, remember it's my fault. Okay, the first impression is that the OODA loop's an organic conception of how the mind operates. The original drawing that we looked at the beginning is a mechanical conception. It's very simplistic. If you go on the internet and start doing research on the OODA loop, the garbage that you're going to see about the OODA loop, it actually absolutely drive you nuts. I mean, there are a lot of people writing about this thing that don't have a clue what he was saying. And usually you'll see some chart like this. I've been in Pentagon briefings where they've shown this, you know, and you just want to vomit. Not that they should be showing this in a briefing. This is just a way of thinking about things. Basically, it's an organic conception, and it can be thought of as a complex interplay of homeostatic control loops and a mental struggle to involve a matchup of living organisms to their environment. And the idea can be applied to individuals, groups, and cultures, you know, with differing degrees of emphasis. We use these ideas in our bureaucratic infighting in the Pentagon for years, and nobody had a clue what we were up to. They really work. So here's the second impression. The only points where the OODA loop comes into contact with the external reality are the action on the right over here and the observations that come in from the outside world. Everything else is internal. And that internal, the internal dynamics has hazards. It has all the hazards that inward focus implies that we've been talking to. Remember Boyd's snowmobile. One can't determine the character and nature of a system within itself. Moreover, attempts to do so will lead to confusion and disorder. The OODA loop is prone to confusion and disorder. And if you think about it in conflict, and I can tell you from personal experience in bureaucratic conflict inside the Pentagon, and I have friends, I have a very good friend who is he's a retired Marine at this point, who has actually used these ideas in combat in Afghanistan, and it works. Basically, the idea here is if your interior operations of an adversary's OODA loop can be induced to hijack his observations and actions, in other words, his orientation starts driving things, then his OODA loop would become isolated from its environment and will be induced into confusion and disorder. I've seen this time and time again in bureaucratic infights, and like I said, my friend who studied Boyd's stuff extensively before he went over to Afghanistan. He was I believe he was a captain at the time. He had a reinforced company. He got into a big battle with a big unit of the Taliban, and he cleaned their clocks using these ideas, getting them to focus inward. So it works. So what can we say about the internal workings of the, wait a minute, of the loop? Take it, I'm open to ideas. There are basically two types of loops. There are two types of loops in this diagram, and one of the control loops is very different than the others. Does anybody have any idea what those are?
Folks, if you want to say something, go ahead and type exclamation mark in the chat. Can you ask the question again?
I haven't heard anything.
Okay. All right. Tom, go ahead.
Okay, I'm looking at the diagram. I find no notion of your purpose or objectives against which all of this stuff can be correlated. Am I missing it?
Right. So the question is, one of the control loops is different from any other. Any ideas on which one that is?
Okay. Let's see, Judith.
The internal one doesn't have contact with the outside. Am I understanding that correctly?
The orientation one, you mean? The one in the box?
Yeah,
Uh,
the one,
You've got a good point there. That's a little bit off this point. The control loops are the blue lines.
right, so the decision hypothesis, and I see an internal one. That's what I thought. Maybe it's not
No,
connecting.
the internal stuff. That loop. Basically, we're going to get into that. I see what you're saying.
Okay.
I'll give you a
Next up.
better explanation in another slide. That's not the point I'm getting at. There's one that's very different. Well, we'll continue on.
There are two more people. Do you want to take those?
Okay.
Okay.
let's
It's
hear
going to be, it's going to be Chase, Jim, and Sanjay. Briefly, please. Chase.
Yeah, the feedback, you're talking about the feedback loop, one that comes from decision back to observation, and the other one that comes from action back to observation. The difference I see between those is decision, a hypothesis feedback is sort of purely internal, and the action test loop would have some contact with external, outside, real world, as you have it labeled.
Well, that's the unfolding. That's the green loop that you're referring. You're right. But that your point is taken up by the green loop. The action goes into the environment, then you have the interaction with the environment that goes back into the observations. But you also have the internal aspect, which is what you hope the action would do. That's a simple way of saying it. You had an intention, and so you see that your action triggered what is in the green, but you know what your action was, so that feeds back. And if there's a mismatch, you got a problem. That's all. But
Jim?
your point's well taken.
Jim?
Yeah, I think he basically answered it. Is that the first loop from the decision triangle is all the possible things that you could do, that you could evaluate very quickly, and then when you decide to do something, that's the action. And the still internal loop on that is your expected outcome from that action.
One's an expected outcome, but that's a standard control loop. That's not a that's not different from the green one in effect. They're just different versions of the same thing. It's like a thermostat.
Jeff.
Thermostatic feedback loop. Yeah.
I guess I see three labels on the blue lines. I see implicit guidance and control. I see feed forward, and I see feedback.
Yeah, that's just the implicit guidance and control is getting at the problem. Basically, if there was someone schooled in automatic control theory, I was hoping someone might be there. They'll see it immediately. Well, we'll go on. We'll go a little bit further. You're actually getting at it, Jeff. But there's a little bit more to it. So let's continue on. Okay, recall that the goal is to improve one's capacity for independent action in a competitive environment of limited skills and resources. And we have essentially two types of loops. We have feed forward loops, and those are the red things here. And if you think about it, that's the energetic aspect of the OODA loop. It's powering the goal-seeking behavior. And the feedback loop are the regulating or goal-seeking. The goal-seeking, I'm sorry. It can be thought of as the regulating of the goal-seeking behavior in the OODA loop as it moves forward in time. In other words, these are the yellow is the control, the red is sort of the energy powering it forward. But there's still one that's very different than the others. Any ideas?
Okay, Elena.
Yes, so what I see, I'm just going back to the previous slide, just that which would have just the first, yeah, this one. So if we look at the icon representing orientation with the diagrams inside. So the orientation itself, and look at the blue line, loop, whatever, it influences the fact of the observation and the action itself. That's what I see different from other loops that are. So it's kind of the fact of orientation, or whatever the orientation is, has a double effect on the world itself, or whatever that on this particular concept.
Okay.
Yeah, I think the orientation is a little bit distracting in this chart. The orientation is basically it's your mental makeup. It's a function of your genetic heritage. For example, you got a right and left hemisphere in your brain. You know, the analysis and synthesis that helps shape your analysis and synthesis. You grow out of a culture that conditions the way you see things. New information is constantly coming in from the outside, and you have previous experiences. There's probably other things that aren't included there, and all that works together in your analytical feedback, in your analytical synthetic feedback thing, the snowmobile operation, snowmobile building operation in your brain. It basically is an expression to show how complex the orientation is. Basically, the observations go straight into the orientation. How you interpret those observations is a function of all that stuff I just described, and no doubt other stuff. I'm not a brain surgeon.
There are two more people.
Pardon?
There are two more people
Okay,
who have a comment. Sanjay and Madeline. Sanjay, go ahead.
Wait a minute. Yeah, go ahead, Sanjay.
Sure. I was going to describe that you have multiple feedback loops that all converge through the, I think it's the orientation process. And that, I mean, in this system, I guess it's good, but also it can lead to a lot of problems because they all rely on how orientation occurs. And it may be that orientation occurs in different ways on different parts of the feedback paths. So
actually, you're getting at an aspect of the problem.
Well, that's what I'm trying to explain is that you actually may end up with race conditions in an infinite condition where you never get out of any of the loops. They all converge through the orientation, so that's a problem.
Yeah, you could definitely have that kind of problem. Let's go to the next slide.
Next, okay, go ahead.
Oh, is there another one? Another person?
There is one more.
Okay.
Madeline.
What I'm seeing is that
Sorry, Madeline, your audio is not working. Jim.
Yeah, I was thinking that upper right blue line, you kind of hinted by making it, shading it in blue as well, is like an instinctive action. You're not
Implicit guidance and control in the upper right-hand corner.
Yeah.
You're right about the instinctive thing. That actually is not a bad thing, and we're going to get into that in a minute. But that's a good observation.
can you hear me now?
Okay, go ahead. Let's try to be brief though.
Yes. Okay. Green in the real world, there are other dissipated structures. In other words, other people.
Sorry, Madeline, can't hear you. All right, let's continue.
Maybe Madeline can get in on another one.
Madeline, you can go ahead and type, please. All right, let's continue.
Okay. The big kahuna that I was getting at is in impression 3. It's the implicit guidance and control loop, or the instinctive loop that was brought up by one of the earlier speakers. Except it's the one that goes into observations. Now, if I take it there's no one in the audience who is involved in automatic control theory. Usually if there's someone in the audience, they see it instantly. This is basically, it's a loop that's disconnected from the environment. It's entirely internal, but it shapes the observations. And as a result, it can drive the loop away from the goal. It's a positive feedback loop, and positive feedback loops are the key to chaos in chaos theory. The OODA loop is very prone to chaos, and it's this in this abstraction, the the implicit guidance and control going from the orientation to the observations is positive feedback. And that's bad news in control theory, but there's nothing you can do about it. And basically what it tells us is the OODA loop, the orientation is modifying the observation. So it's in effect seeing what it wants to see. It amplifies, and the problem is it amplifies its preconceived notions. It's a little bit like placing a speaker next to a microphone in an audio circuit. You know, you just get yourself amplifying, it just amplifies itself over and over again and ends up screeching. The negative feedback loops are basically control loops that dampen variations. They're like the control loops in a household thermostat. Positive. The biggest danger in the OODA loop is that, and this is particularly one reason why, remember, our focus was military operations initially when we were doing this thing. It applies elsewhere. Any doctrinal organization, for example, if you look at the economics profession, you have the supply siders, you have the Keynesians, you know, they're ideologically driven by their set of assumptions. They see what they want to see, and they can twist the data around to make it say whatever they want to say. I don't know if any of you are familiar with all the stuff that's going on in climate science, but what you will find in climate science is they're constantly tinkering with the data observations. They're constantly adjusting them. And many of the adjustments have been shown time and time again to basically support the preconceived idea. It's the same thing. It's basically positive feedback. The problem is this is natural. It can happen to anybody. The more doctrinaire your organization, the more likely it is to happen. If you're in a close group, when you groupthink, the groupthink phenomenon is an example of this kind of positive feedback. Irving Janis wrote a book on psychology in the 70s that was very, very important for understanding how small elite groups screw things up. It's called Groupthink, and the book is an excellent piece of work. It's much more insightful than what you normally read about groupthink. Anyway, it seduces the loop into seeing what it wants to see as opposed to what is. And the orientation distorts the observations, and that can disconnect the organism from its environment, thus isolating the loop, making all loops prone to collapsing into confusion and disorder. That's the danger. That's what Boyd's theory of conflict is talking about. Basically, what you want to do is you want to get you want to get him so confused he starts amplifying what he thinks is going on rather than what is going on, and you march him into the cul-de-sac. And if you look at the great military victories in conflict over time, it's not these head-on bashes where the one who blew the other one away wins. It's the one where all of a sudden your adversary collapses and everybody surrenders. That's when you know you've gotten inside your enemy's head. So when he says, I'm going to get inside my adversary's OODA loop, he has a very specific thing in mind. And that's the purpose of this entire lecture, is to get you a feel for it. It's not this is a gross simplification, but look at what we built it out of. Anyway, that's a vulnerability. All OODA loops embody potential, and your brain is an OODA loop, and your brain is subject to this danger. Everybody's vulnerable to this. Basically, what you want to do is keep your mind loose and accept new things, because you're vulnerable to what we call incestuous amplification. That's a term we coined in the Pentagon for people that just got a bad idea and they kept making it worse. Incestuous amplification. And this is the incestuous amplification loop. Getting back to an earlier comment, the implicit guidance and control, basically, we're talking about reacting. Well, this is particularly important in fast-paced organizations where you don't have time to go through a disciplined decision-making analysis where you're going through what people do. There are different ways of doing it, but basically instinctively you understand the situation and you just pump in the guidance. And you'll see that a lot on a battlefield It's sort of your intuitive, the person who asked the question used the word intuitive or an intuition. That's exactly what it is. If you think about it, at the beginning of the Michelson-Morley experiment, the using of the Newtonian assumptions to shape the experiment were an example of implicit guidance and control. No one took exception to those assumptions at the time. In fact, the results were disconcerting, but they didn't. Most scientists didn't take exception after the experiment. It took years. So the this is okay as long as you're properly wired together. You got a good orientation to the situation. This is what gets you into real trouble. And the rest of this is pretty straightforward control theory. So if you want to summarize things, hold on. I have to move this around a little bit. Yeah, okay. Basically, the danger of incestuous amplification is magnified by the fact that it's implicit, quick and easy, natural, and it's natural. When you're faced with a complex situation, you tend to project your preconceived notions onto it because you don't understand what's going on. And sometimes that works, sometimes it takes you off the cliff. On the other hand, you can use existing repertoires it's also implicit, quick and easy, almost instinctive, very natural. And the orientation actually shapes the action. If you're trying to speed up your decision cycle, this can be very important. And that on a battlefield in particular is very important. The Germans have a great term for that. They call it Fingerspitzengefühl, which is sort of literally the fingertip touch. Basically, it's your intuitive feel for the battlefield. You're touching it. It's like you can touch it all with your fingers and understand it. That's the danger. The rest of this is pretty straightforward. These are the most laborious, obviously, because that's creating new repertoires. If you're in a firefight, the last thing you want to be is down here because you're in real trouble then. You know what you're doing is not working. You understand that you can't do this. So you're trying to take your time and your adversary is has a gun at your head. Remember when we went back to the experiment where we're building a snowmobile and I said, now make a decision with the gun at your head. That's basically, you're trying to go through a loop like this when in fact you should have been up here. Of course, there was no way you could be up there because you had no idea where we were going. Okay. Any questions at this point?
Folks, if you have questions, go ahead and type ! in chat.
I mean, general questions is what I'm.
Sure. So we're going to start with, let's see, it's going to be Elena, Betty, and Mike.
Okay.
Elena. Folks, try to keep your questions brief.
I did ask a question earlier about positive and negative loops, but I think Sanjay answered it. The positive loop increases the signal going into the loop and negative decreases signal. Okay. And yes, so.
Okay, so if you don't have a question, let's go to the next person.
How would negative loop, in terms of negative loop decreasing the signal, why is that the loop coming back to the observation decreases this because of there is not enough feedback? Could you just go back into the concept and explain to me? So that the feedback loop that you call negative going back to observation point, it decreases somehow, so it's marked as negative.
Okay.
Right. Negative feedback loop is a term in control theory. Basically, it comes out of the idea, thermostat's the best example. If temperature goes high, it sends the mercury in the thermometer triggers a signal to turn off the furnace. So basically the temperature drops. So it operates in a negative direction. If it's too high, it tells it to go lower. If it's too low, it tells it to go higher. It's a general term. It isn't negative per se. It just means that it's corrective. Basically, this kind of feedback enables you to in a more general sense, enables you to, you know what your action was trying to achieve. You've seen how it's unfolded, how that action has created some sort of unfolding conditions in the environment. In the simplest case, nothing else changed in the environment. You know what you did for your action, and that's fed back in here. And if for some reason the result is different than what you had hoped for, you have an idea of what to change in order to make it conform to what your goal is. The goal is implicit in this thing. Someone mentioned the fact that it didn't have a goal. The goal is implicit in this. You could say action/goal, and that would solve that oversight. I don't know. Does that answer your question, Elena?
Thank you, Elena. Let's go to the next questions, because there's a lot of questions. But I thought you did a fantastic job. Next up is going to be Betty, Mike, and Michael.
Thank you. When you say one cannot determine the character of a system from within, what exactly does that mean, and how does that relate to getting into the opponent's OODA loop? Does it mean that you can't see the system from within the system? And what exactly is getting into the opponent's OODA loop?
Well, when I say you can't determine the character or nature of a system from within that system, like in Gödel's proof, it basically is, it's something a little bit like the second law of thermodynamics. You can have, the only way to understand, to completely understand a system, now we're talking in a scientific sense, is you have to have some sort of sensory mechanism external to it. Because when you're inside it, your process of observation is part of the internal workings of the system. And when you change anything you do to observe could change what you're observing. If you can look at it from the outside, you may be able to get away from that. Even if your sensing mechanism changes something, you'll have an idea, you can have an idea, not always, but you can have an idea of how that sensing process affected what you were looking at. In some cases, like in Heisenberg type situation, where you have a question of precision equivalence, the act of observing changes what you're observing. But that's all that means. It's a logical, it's basically, I'm getting into a bit of speculation here. It's basically, in my feeling is, it's basically part of the genetic makeup of our brain, of our neurosensory system. It's the way that our hemispheres operate. It's the way we do analysis and synthesis. I think it's a natural limitation. I made a comment at the very beginning about how a porpoise might have a totally different type mental outlook, because it communicates they communicate with each other with the sensor they use to see, effectively, sound. So it's almost like mental telepathy.
Thank you. Next up is going to be Mike, followed by Michael.
Did that help? Did that help?
Sure. Betty, does that answer the question?
Yes, I think I understand that you're saying that we can't be too close to the system in order to see the system clearly. So we have to have space and step back.
Yeah, get outside it. And I mean, it's basic thermodynamics. That's, the one thing we've learned about life is that when you're inside something, that's a prescription for if you're not communicating with the external environment, it's a prescription for problems. And it doesn't matter whether your intellectual construct's inside something or your biological construct's inside something. If you can't communicate with the external environment, you got real problems.
Excellent. Next up is Mike.
Okay, one of the things that you relied on control system theory, and control system theory comes back to how you analyze this after an after-action review of what happened by looking at frame-by-frame analysis. Each one of these loops can either be positive or negative. How a loop that you think is negative can be positive is something called Gibbs phenomenon. You're solving differential equations here and by numerical methods. And so the key to dampening these things is to take a very small step size. You can't see where you're going until you've been to, a little bit of a step size, and then you see whether you're approaching a cul-de-sac or victory. Now, Tom Gilb asked you the question about goal-oriented, and one of the things that I learned from his presentation is something called build a little and test a little. And that's where he was going with the goal. And that's where I think Boyd is going. There was a really big study called 73 Easting, where they did frame by analysis. And you can't see, the observations are statistical, and they could be either positive or negative. Every one of the actions is statistical and could either be positive or negative. Okay. So the key is multiple iterations. That's why it's called a loop. And you do a bit of a test, and then the instabilities, control theory will tell you whether it's stable. And if you take enough pictures, enough samples, you can tell from an after action review what's really went on. So I yield the balance of my time. This is beautiful though, and I've learned a lot from your explanation, and I want to get your slides someday.
Well, Sanjay's got them. So you're going to get them.
Yep.
Have you by any chance, you're ex-military, is that right?
I'm ex-military and also a PhD physicist who's played with this kind of stuff in a number of places. I'm not on the ground thing. The war looks different from 30,000 feet.
Yeah. I was going to say there's a guy named Doug McGregor who was on the spearhead at the 73 Easton, the 73 Easton battle, and I first met him right after the battle. He was in the Pentagon, and he came down to my office to talk to me because he had heard about the work that we had been doing, and he gave me a mouthful on that whole battle, and that wasn't a question of control loops getting screwed up and stuff like that. There was some very stupid decisions made that enabled some crazy stuff to happen.
Well, three guys basically wiped out the entire Republican Guard.
No, they didn't wipe out the entire Republican Guard. They basically neutered most of the Tawakana division. The other Republican Guard guys escaped, and that was Doug's bitch. And that's true. They did. To say they knocked out the entire Republican Guard is wrong. It's simply wrong. The problem was that the Army had a very rigid plan that was they were intent on having artillery fire, and McGregor, who was on the armored cavalry spearhead at the very tip of the spear, was basically in the area. He was approaching the area where they were going to have the artillery barrage, and everybody'd run away. And he called back and said, essentially, these guys are gone. I'm moving in. And they said, no, you're not. We're going to have our artillery barrage, because their OODA loop was so wired into this structured plan, they couldn't deviate from it. And so Doug had to retreat, and they bombarded an empty field.
Thank you. Next up is going to be Michael, followed by Rupali.
Yeah.
Michael?
Yeah, hi. Thank you, Chuck. This is a great presentation.
Thank you.
So my question pertains to the implicit guidance and control between orientation and observations there. I was applying it to a very commonplace non-military scenario, and I think it fits. Like, basically, a company is founded, it has core values that are formed within that orientation loop with all those factors there. It's just implicit. And then as the company grows, let's say from the founder or founders to a multi-hundred, multi-thousand person company, they always, I guess, check in to see if their actions and everything going on are meeting the core value set that they determined onset of the company. I guess I'm seeing where like this, obviously a management consultancy wouldn't be like that's not where you always look or where you turn to see, are we meeting our core values? But I guess I am asking, is it always a danger of incestuous amplification with the example I just provided? Because I'm struggling to see whether you know, management, I guess I'm thinking management alone, it wouldn't necessarily be a danger, would it? I guess, do you see what I'm saying there? Yeah, it's not always. I think the way to think about it is, if you have a organizational culture that was founded, and that culture has certain types of behavioral characteristics that the organization wants to encourage and develop, you can have implicit guidance and control of those feeding back in the observations. In other words, you know, like prohibitions, thou shalt not do certain things, that may affect the way you see things. That isn't necessarily a danger of incestuous amplification. That may be okay. I'm speaking in very abstract terms. The problem is that when the orientation is having disconnects then with its environment caused by the unfolding interaction over here coming back, and you got new circumstances coming in from the outside, the problem is that the amplification can drive you into a situation that makes you essentially move away from your goal rather than towards your goal. Your actions aren't a goal. And remember, your goal is to survive and be on your own terms, basically, and improve your capacity for independent action. That's the most general way of describing it. A company's goal, you know, would fall into that general term. It may have more explicit goals, but they could be subsumed under that general goal. So it's possible that you could have implicit guidance and control into those observations that actually makes things better rather than worse. The problem that you have to always recognize, and I remember I say it's always a danger of incestuous amplification, is when you're in trouble, you start letting your preconceived notions see what you want to see. That's the problem. Your orientation takes over your observations. It basically hijacks them. Then you got a problem. A good example in economics, if you look at some of the neoliberal economics, where a good example is that, let me give you a simple one. We constantly make tax cuts on the promise that tax cuts will stimulate the economy, and that'll create more jobs and improve the economic welfare of the middle class and even the lower classes. What we know is from our history of tax cuts is that sequence just doesn't happen. Now, it doesn't happen for a variety of reasons, but you know, you had Reagan. Well, Kennedy did it, and it sort of worked. Reagan did it. It did not work. It increased the inequality of distribution. Bush the second did it, and it didn't work. And Trump did it, and it didn't work. You know, but we constantly say, if you go back and look at the documents that they were producing, they produced all these economic analyses that said this is what's going to happen. Well, they were just boogering the numbers. I remember I did analysis of the predictions they were making. They were totally ludicrous based on past behavior, but no one cared about that. Now, this is a complex political problem, and the reason why that was happening, was because you had political interests in play. But it was a case of incestuous amplification at the macroscopic scale. You know, a failed formula was applied again and again, you know, and it made things worse, or it was associated with things getting worse. That's a better way of saying it.
Thank you.
It
Next
didn't
up,
solve the problem that they purported to solve.
I've still got some more slides to go, by the way, but we have a few
Oh,
more questions. I just
Sure,
want to,
we'll take 2 more questions and go ahead.
yeah,
Okay, so it's going to be Rupali and Christian, and then we'll continue with the slides.
I hope these answers are helping. It's a little.
Oh, these are amazing answers. It is perfect, amazing. Rupali, go ahead.
So it's actually going to be Rohit who's going to be asking the question. We are both listening together.
Hi, I just wanted to ask, how does orientation change in this loop?
Orientation?
Yeah.
How does it change? Oh, it evolves. Basically, what you have is you have cultural traditions and you have previous experiences. In the short term, your previous experiences, as they change, they will change your orientation. Your genetic heritage is pretty hardwired. Your cultural traditions, well, I can tell from the different people asking the questions, there's a lot of cultural traditions in play here. That affects how each one of us looks at things. And we see the same thing a little differently. I grew up in a period when science, and technology did not mean computers. It meant, better jet engines. It meant, meant all sorts of things. It became computers during my lifetime. Today we use technology. The term technology has evolved over time. That's an orientation. People talk about technology as a thing, whereas it was really, technology is basically the wherewithal for applying science and engineering principles to problems in life. People don't think about it that way anymore. They think about it as a thing. That's how orientation changes. Maybe those aren't the best examples, but think about it. Those of you who are older, ask yourselves, do you see the world differently today than you saw it when you were 20, 25, 30? You see it much different. Time is much different to a 75-year-old than it is to a 30-year-old.
Thank you.
That's how it changes. It's a growing phenomenon. It's an evolutionary, that's why I call it evolutionary epistemology. The orientation is changing. It's not fixed.
Thank you. Next up is Christian.
Yeah.
Yes, thank you. Wonderful presentation. I wonder about Boyd's emphasis on the implicit. I have this impression that he is very much a fan of implicit guidance and control, if you could put it that way, versus explicit and formalized materials, especially in an organizational or social context. It's like he went so far with the implicit that he didn't even write a book about his ideas.
You're completely correct in that. He put great evidence on it. And I can tell you exactly how he came about getting so. I think he instinctively had the kind of value toward the implicit that you're referring to. It at least grew out of his experience of being a fighter pilot at Nellis Air Force Base in the 50s, because a lot of that stuff is instinctive. So I think he was prone in that direction. A lot of fighter pilots do things implicitly because things are so fast and you're moving in three-dimensional space. But I can tell you we didn't talk about implicit that much until he started looking at land warfare. And we in the 1970s, in the late 70s, in the early 80s, we had a series of interviews with German military people who fought in World War II. Several of them were generals, and we also interviewed a very famous Stuka pilot, the most famous Stuka pilot, Hans Rudel. But we interviewed several generals, and one of the generals made a huge impression on John. His name was Hermann Balck. Balck was the most decorated German general in World War II. He survived the war. He spent most of his time on the Eastern Front, and he survived. And Balk was very much into, they would constantly talk about sort of the implicit nature of the battlefield. Rudel was the same, Hans Rudel, the Stuka pilot, was the same way. He was the one that acclimated us to the terms Fingerspitzengefühl. He was talking about how if he went home for 2 weeks and he came back, that was when he was most vulnerable, because the battlefield had just changed in little tiny subtle ways and he'd lost his Fingerspitzengefühl. And so basically what you do, where your life is on the line, where the life of your friends are on the line, you basically have to develop this quick reacting stuff that it's implicit. You do it almost without thinking. You talk to anybody who's been in a firefight, any experienced infantryman who's been in a firefight, he'll talk about this. And I think Balk in particular, but also Rudel, made a huge impression on him. Well, I know they made a huge impression on him. I'm not, because of the way they talked about how they would keep in touch with things. Balk made a big deal about going at the front and finding out how his troops were doing and eating the same food they eat and sleeping at night out in the front lines and stuff like that. And, so he was really in touch with the people at the pointy end of the spear. And that was sort of he was building up an implicit repertoire. The other thing they did, and I hate to make this, this OODA loop goes way beyond military, but in some ways, the best laboratory case of an OODA loop is military, because it's a life-threatening situation, fast-paced, where you can go through this kind of explicit thing and come up with the right answer, but you're dead because it took too long. The implicit thing is important. The thing that we really became impressed with the way the Germans developed their whole command culture and the relationships they had with their enlisted men, the officers and the enlisted men. Each person, for example, had to understand the general plan of operation 2 levels up. So if both of the people who were commanders higher up got killed, this guy could move into their place. They did not, their orders, their mission, they operated on a thing called mission orders, where they basically, when orders came down, it wasn't how to do something, it was what to do. And you could figure it out on your own. That earlier question we had on 73 Easton, where my friend Doug McGregor, was going crazy because he had to retreat an area that they had already left from, because we were going to do an artillery barrage, is the exact opposite. It's when you have detailed mission orders that took a week to prepare, and then you can't deviate. The Germans had a system that you could deviate, and it was based a lot on what was not said as opposed to what was said. That's the best way to describe it. And the thing that is interesting, and I have a few slides on military in a little bit, maybe I can make it a little clearer, but what makes this really interesting, it's a general concept. And as I showed you earlier on, it certainly applies to science, which is a very deliberative, not procedural, but a very deliberate, conscious process when it's done right. The military thing, where you have to do things fast and you have imperfect information, and you have to act. You got a gun at your head, basically. You got a confusing situation with a gun at your head, and you have to feel your way instinctively out of it. You don't have time to do an analysis and a hypothesis and making decisions and stuff like that. That's why this loop, the implicit guidance and control loop, is so important. And that's why the implicit loop into observations is so dangerous, because it can happen so fast, and then everybody lines up and it just amplifies itself and you go right off the cliff. Does that help you?
Yeah, great. Thank you.
Okay. Now, do we have any more questions? Or are we ready to
No,
move?
let's move on.
Okay. Well, anyway, you can see that there's a lot that you could talk for hours on this thing, and there are a lot of different ways of looking at it. Now, here's some examples. Here are some examples, and remember, this briefing was tailored for the Marine Corps or the Naval War College. It was tailored for basically military situations. But And attached to the end in Appendix A and B here, I have some examples that you can read through and figure out yourself. But a good example of how the danger of this implicit of the incestuous amplification is France in 1940. The original German plan for the invasion of France in 1940 was basically, originally it was going to be a rerun of the Schlieffen plan of World War I, which was basically to go through Belgium, because that's the flat country. Most of it's the flat country, except for the southeast corner, which is the Ardennes. But the Germans became concerned. The Germans became concerned that their plan had been compromised. So they changed the plan. That in itself is an interesting story. I won't get into that, but they started off with the Schlieffen mentality, basically doing the same old thing. They eventually came up with a very different plan. The French decided they were going to refight World War I too, but they stuck to theirs. Theirs was the Maginot Line. And basically what they did was they built a super trench, the world's most technically advanced trench. But it only went on the border of France. It ended at around Luxembourg. So basically the plan was that we'll move our forces from where it ends up into Belgium and form a line to the sea, just like they had in World War I. What the Germans ended up doing is they played into that mentality, and they went through the Ardennes, right through Luxembourg. And then instead of turning toward Paris, like in the original Schlieffen plan, they turned toward the coast, and they bagged the British and the French and caused the collapse in 6 weeks. It was an example of, if you go through that campaign, you can see how basically they were seeing what they wanted. The French were seeing what they wanted to see, and they didn't understand till the very end how bad the situation was, and then they collapsed. They just walked into the POW cages. The French and the British together had more tanks than the Germans. They had more airplanes than the Germans. And the French actually had better tanks than the Germans, but they still got wiped out. Another one was the invasion of Normandy, where we had the ultra secret, we were reading the German mail. And basically they created this phony army around Patton to convince the Germans that we were going to land at the Pas de Calais and that Normandy was a deception. And the Germans fell for it, hook, line, and sinker. And we were able to establish our lodgment before they figured out it was the main effort. And in Vietnam was a classic case of incestuous amplification, wiping out a OODA loop. In our case, our OODA loop, because we're measuring our success by body count. But if you look at guerrilla warfare doctrine, particularly Maoist doctrine, which is what Ho Chi Minh was using, maybe better than Mao used, the basic doctrine is you don't get into big battles until you're winning. So naturally the body count goes up. So what's the body count measuring? Is it measuring your success or failure? And bombing was the same way. We just measured tonnage dropped. That was how we measured success. And Nazi demon, that's self-explanatory. Remember Saddam's weapons of mass destruction? That was a classic case of using an orientation to shape observations, to convince people, in this case, it was a propaganda campaign to convince the American people that we had to go to war. And, I think the key one here is the Michelson-Morley experiment. They basically provided the counterexample. Unfortunately, it's in science. It's deliberate and time consuming, but they basically did their experiments over and over and over again. And finally, they determined that their experiments, they couldn't find an error in their experiments, and they knew something had to be wrong somewhere, but they didn't know where. And it took another 25, 30 years to figure it out. Anyway, one of the things that's nice about this kind of thing is you can use it as a tool to do a case study to examine things like, how does organizational culture affect the way your company is interacting with its environment? Is your organizational culture twisting observations in a non-productive way, or is it helping them? Is it helping you have better ones? There are different ways you can apply it. It's just a way of thinking. Okay. So basically, in summary, what we're dealing with is an analytic synthetic interaction by which a mental orientation connects itself with the external world. And in a thermodynamic terms, I guess, it's an evolving, open-ended, far from equilibrium process governed by control loops embodying positive as well as negative feedback. And remember, negative doesn't have a value thing. It's just an inverse relation, control loop like in a thermostat. And positive is amplification. The entire loop is an ongoing, many-sided, implicit cross-referencing process of projection, empathy, correlation, and rejection. It's basically getting yourself closer to your environment. And that makes it an unpredictable evolutionary phenomenon, and it's always prone to chaos. But think about it. On the other hand, when things really get out of whack, like they did in the Michelson-Morley experiment, or they did during the slower paced destruction of the Ptolemaic universe, new and strange things happen. That's when we learn things. So it's a learning device more than anything else. It can be fast-paced learning or slow-paced learning. And that brings us back to Boyd's bottom line. If you remember his snowmobile, basically it's defined by this revelation in a sense. And that's it. We're done. Now I'm open to any general questions or anything. I'm sure everybody's pretty tired.
All right, folks, if you have questions, this is your last chance to ask questions. So I'm going to give preference to people who have not asked the questions before. So it's going to be David. David, go ahead.
Yes, thanks very much. And thanks for this great presentation, Chuck. I mean, one brief comment and a question. I mean, one is if you've heard of Erich von Hippel and his work on innovation, which very much relates to this snowmobile idea. And the specific question was, if you could give more an example of how exactly to create this, I'll call it overload, or saying this problem with orientation. Is there a specific plan about how you cause the enemy to get into this overload where they're looking at the problem themselves and they get overwhelmed by the orientation phase?
Well, I mean, about the innovation, I'm not familiar with that. What'd you say? Hippel was his name? Is that?
Yeah, Erich von Hippel is a professor at MIT.
Yeah, I'm not familiar with that book or what his theory is, so I can't really answer the question. In a general sense, if you look at in a conflict situation, which could be a bureaucratic conflict, a business conflict, which by the way, Chet Richards is the only person I know who has actually tried to apply these ideas, who understood the OODA loop anyway, to business situation. He's the only person that's really taken Boyd's work, in my opinion, a step further. And John felt that way too, by the way. He felt Chet was doing that. He didn't see Chet's final stuff, but because he died. But as far as the question was,
well, is there a specific
repeat it
strategy?
Again? I'm sorry. I got distracted by my own talking.
So no, is there a specific strategy or a specific plan about how to cause the enemy to get into this situation where they're overwhelmed by the orientation? I mean, is there?
Well, yeah, there are ideas about how the strategy. Remember, it's going to be scenario dependent. If you look at John's briefings on patterns of conflict, that's stuff that was in the middle. Remember, I showed you the bookends, and this briefing was about the left-hand bookend. If you look at the stuff in the middle about there, he describes how these strategies are, and you can evolve strategies out of that. There's no checklist you can go through to figure this stuff out. It's so scenario dependent. I know we basically provided, when we were doing bureaucratic warfare in the Pentagon, which is a lot like combat. I've never been in combat, but I have many of my friends have been in combat, and they've told me many times that, you know, it was like combat, bureaucratic warfare in the Pentagon. And basically what you do is you when you're doing this stuff, you get in sort of an instinctive feel for stuff, and you do things naturally that basically cause them to cause your adversary to over and under react on time, in time. And over time, as they over and under react, they get, this is very abstract, but they get further and further away from their goal. And if you can apply menacing pressure, now menacing pressure in the Pentagon takes the form of having your budget reduced or possibly your career wrecked, things like that. It doesn't mean you're going to die. But if you can put it under menacing pressure where they have to make decisions, they progressively, they just come apart at the seams. And I've seen it with my own eyes. As far as building a strategy, what you really do is you get a Fingerspitzengefühl for it. That you would, if you were operating at a tactical level. Now at a strategic level, you might think about it a little bit differently, but the last thing you want to do is start thinking in terms of having a checklist to go through. I'm going to do this, I'm going to do this, I'm going to do this, and it's going to get inside his OODA loop and it's going to turn inside himself. What you do is you show the person that his basic assumptions don't match, his actions and assumptions don't match up to reality. And the way you do that is as they get more and more active and they move further and further away from reality, you reinforce that as it goes along. That's about all I can say.
Thank you.
You need to stay open.
Thank you.
Sorry.
No, this was great. Next up is Jeff. Jeff, go ahead.
Chuck, thank you for such a remarkable presentation. And I'm struck a little bit by the the method here, and how it can preserve or protect or increase the ability for independent action for an individual, like somebody flying a fighter jet, competing with somebody else flying a fighter jet, and the things that you've emphasized regarding the traps of groupthink and confirmation bias, and of a system, as you were just saying, not only not rewarding the noticing and reporting of things that really are different from what the expectations were, but even having, either formally or informally in place a culture that penalizes it. And I'm wondering what you might offer with regard to leadership and organizational culture, the methods and any messages that can help to overcome those kinds of things that get in the way.
Oh, that's a really, I wish we had this discussion while we were talking through some of the loops. You hit a lot of nails right on the head. Confirmation bias, for example, that was definitely embedded in what I was saying. As far as answering your question about how you would change organizational culture, I mean, you're looking at a guy who was part of a group that failed to change an organizational culture. The Pentagon, it didn't change. We had them on a run for a while, and I can show a chart. I don't have it here, but I have a chart that shows that we basically, cleaned out the budget plans for escalation, super spending escalation in the mid 80s. We wiped them out. But as far as changing the culture, things have just gotten steadily worse. and there are so many interests in play. My experience is not in the private sector. In business, I don't really know much about small organizational culture. I can imagine it, but I don't have any experience in that. I was in the biggest organization in America, and basically I can talk to you about how dissidents behave in that kind of culture. It's an authoritarian, top-down culture that runs on its own steam, and basically facts that do not conform with preconceived notions just get stomped on, and what it does, and I'm sure this applies in some way to smaller companies, but the way leadership can suppress innovative thinking is simply by restricting opportunities for growth, promotion or education or however you want to look at it. In the military, it's extremely subtle. Have you been in the military, or yes or no, or?
I've not, but I have. I've worked in and consulted to folks in very, very large systems.
Yeah, well,
and so
I'm sure what I'm about to say is, in the military, when they're evaluating people, they have a very formalized efficiency reporting system, which also a lot of corporations have, and basically it always gets inflated, where everybody's great. And so the kiss of death can be very subtle. Basically we used to have a joke about officer efficiency reports that, you were screwed if you walked on water slowly. and what that would do is, if you think about it, people who are trying to climb the greasy pole, they basically fear that kind of epithet, walk on water slowly thing. So they become timid, and they don't, when they see problems, they come at them so indirectly that the bosses may not even know there's a problem. And if they see their bosses are going in another way, in another direction, they think it's totally wrong, they don't open their mouths, because then they know they'll get truncated. And that culture then permeates your whole thing. And in fact, the people who get promoted the fastest in that kind of culture view themselves as having the most to lose, and they're the most fearful. And I saw that over and over again. Whereas people that graduated from the best schools, who got promoted ahead of their contemporaries and all that, they were the most useless people in the Pentagon. You raised good points.
Fantastic. So Chuck, this was such an honor and such a delight. It's just amazing. So thank you so much. Really, really appreciate it.
Okay, well, I hope it helped.
Yeah, no, it was wonderful. Okay. And thank you everyone for great questions. This, we were worried about the interactivity. I thought it worked out well, right?
Oh yeah. The problem was occasionally there were the only problem with it was the garbling.
Yes.
The occasional garbling, but it was fine.
Yeah, wonderful. Thank you, Chuck.
Okay, my pleasure. Bye.
Have a nice evening.
Okay,
everybody.
Bye.
Bye.